guys, it's Dr. Bay and here's Bugsy, and today we're going to go over Introduction to Amine Reactions, so stay tuned.
Organic chemistry,
taught by Dr. Bay.
Reaction mechanisms,
Reactants to products.
Retrosynthesis,
Target deconstructing.
molecules, spectroscopy. Soaring through the sky, triumphantly fly. Give rise to the complexity of life. Living on a dream across the 7 seas. Learning about spectroscopy. Organic chemistry.
Amines are either ammonia or NH3, or they are compounds that contain a primary, secondary, or tertiary amine, depending on the number of carbon atoms that are connected to the nitrogen atom. Amines can be found in many molecules found in nature, as well as many drug molecules. Some examples are adrenaline, which is a fight-or-flight hormone in our bodies, dopamine, which regulates motor skills and emotions, and nicotine, which is an addictive and toxic compound found in tobacco. Some previous ways to form amines are an SN2 reaction using NaCN to form a nitrile, followed by reduction of the nitrile to a primary amine using an excess amount of LiAlH4. Another way to start from a carboxylic acid and to convert it into an acid chloride using SOCl2, followed by an excess amount of ammonia to form an amide, then reduction of the amide to a primary amine. And another way is to undergo an electrophilic aromatic substitution or EAS reaction, specifically nitration, to add a nitro group to an aromatic molecule, followed by reduction of the NO2 group to an NH2 group using either iron or zinc with HCl, followed by NaOH. Azide synthesis is a better way to form exclusively primary amines. The first step is an SN2 reaction with sodium azide or NaN3, followed by reduction of the azide to a primary amine. The mechanism starts with one of the lone pairs on nitrogen attacking the alpha carbon, followed by the Br leaving group breaking off. Then one of the hydrogen-aluminum bonds attacks the nitrogen atom, and the pi bond forms a new lone pair on the middle nitrogen atom to form the following negatively charged intermediate. Then one of the lone pairs on the negative nitrogen forms a triple bond, and the nitrogen-nitrogen single bond becomes a new lone pair on NH. Then water comes in to protonate the negative nitrogen atom to form a primary amine. Gabriel synthesis is another way to form exclusively primary amines by using a reagent called potassium phthalimide as shown below. The mechanism starts with this reagent getting deprotonated with KOH to form the following negatively charged intermediate, which acts as a nucleophile to attack a primary alkyl halide via an SN2 mechanism. Then hydrazine, or H2N NH2, is used to undergo hydrolysis to form a primary amine. You do not need to know the mechanism for the last step of this reaction. And lastly, reductive amination converts either a ketone or aldehyde into either a primary, secondary, or tertiary amine using sodium cyanoborohydride. If a ketone reacts with ammonia or NH3 along with H2SO4 and NABH3CN, a primary amine is formed. If a primary amine is used as a nucleophile instead, then a secondary amine is formed as a product. And lastly, if a secondary amine is used as a nucleophile instead, then the final product is a tertiary amine. So in summary, there are a total of 6 ways to form amines. Some ways that you've learned in the past are an SN2 reaction followed by reduction, formation of an amine from a carboxylic acid, and nitration followed by reduction. And new ways to form amines are via azide synthesis, Gabriel synthesis, or reductive amination.
Organic